little different. So if you could, you have to go ahead a few slides. Can you guys find this in your notes? Okay, cool. Very good. Looks like it's on a page 5, page 5. And so actually that last problem that you guys handed in, we're going to apply that grams to grams to this problem, okay? So this is balanced, okay? Notice we know it's balanced because if we were to go ahead and put a little, there between reactants and products, we come up with 4 P's on both sides. And can you see where we have 6 CLs on both, 12 CLs on both sides? Okay, does that make sense? We all buying that? Okay, so it is balanced. Okay, and then your next slide does a little animation. We've already seen that animation a few times, I think. Okay. But here's the problem. And so here's kind of what I had in mind. We're going to do the first one together, and then the other one you're going to do on a separate piece of paper. Okay? So, and this is like that last problem for your homework. And this is going to be like the homework that's going to be due Monday. It's a really classic. So sometimes what I'll do, and I didn't do it before on Wednesday, but sometimes what I'll do is I'll say what mass of P4, so for this first problem we're going to do together, I'll put the question mark under P4, so question mark under P4. What mass of P4 is needed to react with 1.25, and I'll put 1.25 grams under the Cl2, okay? That just is a way to kind of diagram the problem. So basically, we're going to go from grams of Cl2, not 6 Cl2. We're going to go from grams of Cl2, okay, to grams of P4, question mark grams. That's what we're going to do together. And then for the second one, it's similar. It says what mass of PCl3 can be produced. So for the second one, question mark grams over here for the PCl3. And notice for that second problem that you're going to do on your own, again, you have 1.25 grams of Cl2. Okay? So, yep. I think the strategy, I lay out on the next one. So I don't know if you have this in the next slide. In order to work both of those problems, as we talked about on Wednesday, you're going to need the molar masses of both what you know, which is the Cl2, and you're going to need the molar mass of what you're trying to go to. In the first case, it's P4, okay, and in the second case, when you guys do it, you're going to need the molar mass of PCl3. So I went ahead and kind of knocked these out. So do you guys already have these on your thing? Okay, good. All right. So I guess I don't have strategy. Let's just go ahead and diagram the strategy together, okay? We're going to start out in this case with the grams, specifically 1.25 grams of Cl2, okay? And then we're going to go to moles of Cl2. We're going to do that using the molar mass of Cl2. And then we're going to go from moles of Cl2, what we know, to now moles of what we're trying to get to, which in the first case is the P4. And the way we're going to accomplish that is the stoichiometric ratio. And what you do with the stoichiometric ratio, that kind of third term in your stuff to multiply together, is what I usually do is I kind of draw a line. I don't know which one I go for first, but the thing I want to convert from is moles of Cl2, so that goes in the denominator, moles of Cl2. The thing I want to convert to is moles of P4, so that's going to go in the numerator, moles of P4. Okay, this is my stoichiometric ratio. And then the number in front of those moles of P4 and moles of Cl2 I get from the balanced chemical equation. So that's why for the numerator, for the top one, moles of P4, that we're going to go with 1 there. It came from that 1 right there. The number for the moles of Cl2 is going to be that 6. And that 6 came from the balanced chemical equation. So once we have moles of P4, then we can get to grams of P4, kind of finishing up, I'll kind of wrap around here. And we do that, of course, using P4's molar mass. So you can break it up into 3 different problems, but I like to just kind of string them up. Okay, so here's what this looks like. The mass of Cl2 over 1.25 grams of Cl2. We said next on the track is to go to moles. So if we want grams of Cl2 to cancel, can you see where we're going to use the flipped version of the molar mass of Cl2? So 1 mole of Cl2 to 70 per 70.90 grams of Cl2. So grams of Cl2 will cancel. Okay, now we're to that middle term, the stoichiometric ratio. So we want moles of Cl2 to cancel. We want to be left with moles of P4. And this is the one where you take those whole numbers from your stoichiometric coefficients. So that's why we went with 1 mole of P4, because the coefficient in front of P4 is 1. 6 moles of Cl2. Coefficient in front of Cl2 is 6. So the moles of Cl2 cancel. And we're almost done. Now we need to use the molar mass of P4 to get to grams of P4. So we use the unflipped version of the molar mass of P4. Okay, so 123.88 grams per mole is what we have. So 123.88 grams of P4 per 1 mole of P4. And you really have to go ahead and say what your species is in each of these cases. So moles of P4 will cancel. We're left with grams of P4, which is perfect. Notice that if you look back at the page before where I knocked out the molar masses for everything, okay, the molar masses, you do them with blindfolds. The molar masses is independent of the equation you're using. You do not use the stoichiometric coefficient to come up with molar masses. Okay, that's a common mistake. So round to 3 sig figs, okay, looks like this, 0.364 grams of P4. So I'll give you a little bit of time. You can work together, you know, this isn't that sort of quiz. But I want you to do the same thing now for this one. And you can even, yeah, I want a separate piece of paper so I can take a look at it. So in this case, just like we said, this is problem B. Basically, you have that 1.25 grams of Cl2, and you're supposed to get to grams of PCl3. So you're going to have to hand, if you want extra credit, you're going to have to hand me in a piece of paper. And actually today, you're in luck because we're going to do this twice. So you'll get 20 extra credit points. Okay, so this is 10 and the next one's 10. What the heck?
When it says and sufficient P4, do you want us to also do the calculation for P4 as well?
No, that just means
It's just
that
assuming that, yeah.
that's
there's
it's in what we call
yeah.
excess. So actually, probably on Monday, we'll talk about limited and excess. So,
And I am,
I think you are. First two terms will be the same in this case. Yep, that's right. So now you want to go to moles. You want
two random numbers out of the whole infinite amount of numbers.
Yeah, I get it.
Because it's all canceled, isn't it?
What's the next number? Is it?
Right, right, so.
Oh, someone's got that too.
Because that's PCF. How's that canceled?
The other part of Molar Masses is it's per one mole. Can we do it? I like it. Very good. It's always going to be on the Molar Masses.
I calculated it easier. It's easier to do it all the way across than then do the bottom. Okay, now I know how many students get figures.
Is that what you like?
It's four.
Ah.
So go ahead and write what you're going to write. See, we told you, right, we're not going to people, we're going to PCF for you.
I wouldn't even use that. Learn how to do that.
It changes it up. Okay, so this one up here. So down at the top, the thing about this one is that has to be formed. And then on your right, since you want this to cancel, you're gonna go with six. Do you see where those six came from? And so it's always gonna be the mass, it's gonna be a molar mass, a ratio of the molar mass. So this is the molar mass now.
Show it in your copies.
Getting there. You write so hard, you know, I think you break it down.
Who would like to say it on the table?
Yeah.
It's looking good. So you did that. Yeah, so this one is, yeah, this one you use the unflipped version because, oh, I know. It's, see here, this actually, when you read this number here,
Orientation that goes in like.
okay, that's 137.32 grams per 1 mole, and you have it 1 gram per 137.32 moles. So,
Yeah.
but I like what you're doing, factor label, that's right.
I'm hoping I'll have to print off all my stuff. Other than my CPR.
Rats.
So it's always gonna have this pattern. What? Oh, rats, it does look like rats. That's ratio. Goodness.